right, so this week we're going to take a look at 3 sections. Okay, so we have 3 lessons. We're going to split 5.1 up into a couple days. We'll do part today, part tomorrow. As I said, the next section we're going to do is an appendix in the back of the book. It's more of a review section from Algebra 2 on complex numbers. And then we're going to come back to Chapter 5 to do the very last section of the week, which shows you the connection between what we're going to do today and the section we're going to cover in the back of the book. It's really 5.3 Part 2 that shows you that connection. Because of the Veterans Day, we're not going to get to that section, but that's still the plan for this week. 5.1, A4, and just the first part of 5.3. We will not be doing the second part. Okay? And then test on Friday. So first thing we're going to look at is just a different way we can graph a coordinate, okay, besides using this kind of graph paper. Okay, so this is the kind of graph paper we're used to using. It's got 2 axes, the horizontal and the vertical. Ben, what's the name of the horizontal? Yeah, that's your x-axis. And Jaden, the name of your vertical axis? Y. So we're used to having an x and a y axis, and when you want to plot a point somewhere on this coordinate system, you need to write something like this. You have to give me 2 numbers with a comma between them, and we call that an ordered pair, or a coordinate. X can be a positive or a negative number. Positive would be going to the right, negative would be left. And y can also be a positive or negative. Positive is up, negative is down. Well, we can also graph things using a different system, and that's called polar graphing, okay, or polar coordinate system. And what I'm going to do is I'm going to show you a graph of something on the calculator. Okay, so you don't need a graphing calculator. I'm just going to show you something, and I'm going to show you the same graph in this system, and then I'll show you the same graph in this system. And depending on what you're trying to graph, there are advantages to using one system over the other. It's like different tool depending on what you're trying to do. If you just want to graph lines using an XY axis system, very easy, very simple. That's probably the best way to do it, the way you've been doing it since Algebra 1. But a polar coordinate system is helpful when you want to draw things that are circular. And I'm going to show you how complicated it is to draw something circular on an XY axis. And then I'll show you how simple it is to do it in polar. Okay, just by the amount you have to type in on the calculator to do it. So in a polar system, the way the graph paper looks is it's kind of like these rings coming out from the center. A lot of times they divide it. Let me show you how it looks here. They put these rings from the center, and then they divide it into different degree increments. So let me just zoom out a little bit. So I think on this one, they're all separated into 15s. Right, so 15, 30, 45, 60, 75, 90. So you can have more or less. It just depends on the graph paper you're using. But I think most of the ones that I use will go by 15s. Sometimes they go by 10s, so to separate it. And you'll notice when you write a coordinate, there are 2 parts to it, just like a coordinate in an XY system. We'll talk about what each part means right now. They generally call the horizontal axis the polar axis. And they call the center the pole. You can also call it the origin, but a lot of times they call it the pole in pole. Okay, and I'll do the graphing calculator thing in a minute, as soon as I explain what a polar coordinate is. So like an XY coordinate, it is written with 2 numbers in parentheses with a comma between them. But the 2 numbers mean different things. It doesn't mean x and y anymore. Okay, in polar, what it stands for is R and theta. Now we're dealing with a coordinate system that has these circles, like these concentric circles. So does anybody have a guess what R might stand for, having to do with circles, Pete?
The radius?
Yeah, it has to do with a radius, or a distance from the pole. And theta is a Greek letter. What do we usually use Greek letters to represent in trig? And if you looked at the next problem I already showed you, you could see what it kind of means, yeah? It means it's an angle. So when we graph something in polar, we have to measure a certain distance from the center, and then we rotate a certain amount of degrees. Now, just like x and y, one of these numbers can be positive and negative. Positive and negative will control what direction you move in. When we do things in polar, we're not going to be graphing full pictures. The most complicated thing we're going to graph is a single point. That's it. Just a point. In polar, you can graph all kinds of things. I'll show you some graphs you can do in polar, but it's really something I focus on more in pre-cal because we spend a couple weeks on this versus just spending 3 days on it. Okay, so we're only going to be graphing single points. The next step would be to graph something more, like a whole picture. Okay, but we're going to practice just single points. So the first thing you have to do is you look at R, and you're going to move out the number of rings indicated by R. Now there are two directions you can move. And it's going to depend on if R is positive or if R is negative. Bless you. Okay, if R is positive, it's kind of like if X is positive. You can kind of treat it the same way. If R is positive, you're going to start at the pole, and you're going to move to the right. How many units are you going to move? However much R is. If R is 3, you'd move 3 units right. If R was 2.5, you'd go in between the second and the third circle. So you can go in between the circles just like you can go in between grid lines with XY coordinates. So if R is greater than 0, we're going to start by moving to the right. What do you think is going to happen if R is less than 0? Which way do you think I would move, Jess?
Yeah, to the left.
Yeah, to the left. How many units? However much R is. All right, we're going to practice graphing several examples with coordinates in a little bit. So if R is greater than 0, we're going to move right. If R is less than 0, we're going to move left. Now, theta, that's the second number that you write down in a coordinate, represents an angle of rotation. Well, when we talk about rotating on a circle, the two directions are not really left and right or up and down. What are the two ways that you can rotate on a circle? How do we describe those two directions? Yeah?
Clockwise or counterclockwise?
Yeah. It's either going to be clockwise or it's going to be a counterclockwise. And that's going to be determined whether or not it's a positive or a negative. So, after you do step 1, if the angle that they gave you was greater than 0, we're going to move clockwise, or counterclockwise. And counterclockwise is this way, if you're not sure. Okay. So if the angle is greater than 0, we're going to go counterclockwise that many units. The two units you're most likely going to see are degrees and radians. As always, if you have something in radians and you're not sure what it means, you can always change it to degrees yourself. All right, so if our angle is positive, we're going to go counterclockwise. What direction do you think we would go if the angle is negative? Yeah,
Clockwise.
we're going to go clockwise. So if you have an angle that's negative or less than 0, you're going to go clockwise. Clockwise is that way. Alright, now before we practice some points, we're going to do all the different combinations you can have, like a positive radius and a positive angle, positive radius, negative angle, we'll try them all. But I just want to show you a couple graphs on the calculator. And the first thing I'm going to do is I'm going to graph a circle. And the point is I want to show you how complicated it is to type in a circle using an XY coordinate system. Okay, you can do it, but it's not the best tool. If that's what you have to draw, things that are circular, XY coordinates are not the simplest way to do it. So I'm trying to show you why we would use polar. Okay, why? Why do we have this other system? We already have a system. Well, it's not always the simplest system. All right, let me draw you a circle that has a radius of 3. Could make it as big or small as I want. Well, if you draw a circle on here, I can't even draw a circle as one piece. I have to draw it as 2 pieces because the calculator can only draw things that pass the vertical line test if I'm using the XY coordinate system. Well, a circle fails that. A vertical line test means if you can put a vertical line in and it hits more than once, it fails the test. So the calculator can only draw things that pass the test. So the way I can kind of cheat and make a circle is draw the top half, which passes the vertical line test, and then draw the bottom half separate. That's the only way I can do it with a graphing calculator. So already that's a little more complicated. I have to draw the top half and the bottom half separate. All right, so, and then you need to know the formula to do that. And the formula, it's not too complicated, but it's also not the simplest thing. Okay, again, you don't have to, now it should be 9 minus x squared. Let's say it's very easy to mess this up. 9 minus x squared. Okay, if I do that, it's going to give me the top half of the circle. Now let me do the bottom half. 9 minus x squared. And let's see what that looks like. So there's the top half. There's the bottom half. And it doesn't even really look like they connect, but that's the best I can do. That's just how the calculator does it. And this is what I had to type in to get that picture. Now, let me show you the same thing, but doing it in a polar system. So on my calculator, this type of graphing calculator, I can just change the mode. Probably can't see it that well, but from an XY system to, and it says polar right under that black box. It was blinking when I captured it. So it says polar. I'm going to change it to polar. And now, let me show you how I would graph a circle of radius 3 in polar. I'm done. That's the whole thing. So all I had to do was type in a single number, just like that. I typed in 3. Let me hit graph. And I think my calculator froze. Let me fix that. 0 to 2 pi. Take graph. Okay, let me fix it now. I don't know what I hit something to make it. Bless you. My calculator has frozen. Why? I don't know. Well, I can draw it like that, which kind of looks like an oval, but it really isn't. It's just the way I'm zoomed in. It is 3 units this way, 3 units this way, 3 units this way, and 3 units that way. It is 3 units in every direction, so it is a circle. It's just my calculator's being a little strange. But the point is, look how much less information I had to type compared to that to draw a circle. I just have to fix my window, which, again, I don't know why it was freezing on me. So some other things we can draw in polar that you can't even really draw in an XY coordinate system is you can draw something like, let's zoom out and see if you can see what this looks like. Zoom out even more. So I can draw things that look more like a spiral. So it's not really something we can easily draw with an XY coordinate. I could also draw, let me type in something like 2 cosine. Let's see what this looks like. Zoom in a little. I don't know if you can see that well. It looks kind of like petals to a flower. So we can draw that. When if we change certain numbers, we can control how many petals we have. Let's make that a 5. Right? Now I get 5 petals. So things like that we can't even really do with an XY coordinate system. Right? It's too complicated. But in polar, it's a lot simpler. So this is the next step we would take after we learn how to graph points. This is not something that we ever really get to in this class. But there are all kinds of different graphs you can do that look pretty neat. All right. So we've got the directions here for graphing the coordinate. So let's see if we can graph some coordinates. Zoom out a little bit. All right, so the coordinate they've given me is 3, 120 degrees. So Raymond, what's my R in this case? 3. And are we going to start by going 3 units right or 3 units left?
Right.
Yes, correct. We're going to go 3 units to the right. I'm just going to put a temporary mark right there. I'm going to erase that. But that's where I'm starting from. 1, 2, 3 units right. And now from that point, I'm going to rotate 120 degrees. We just have to figure out if it should be counterclockwise or clockwise. Colby, which way am I going to go in this case? Counterclockwise or clockwise?
Counterclockwise.
Yep, we're going to go counterclockwise, 120 degrees. So on the test, you're going to have a piece of graph paper on the screen that's labeled like this. So all you're going to have to do is click where you want to put your point. Right, so we're going to go 15, 30, 45, 60, 75, 90. How much past 90 do I have to go to get to 120? 30. So another 15 and 15. And that's where the point should be. Okay, any questions on how we graph that one? Okay, and that's it. All right, let's try this one. So it's still a positive radius and it's still a positive angle. Lacey, what's different about my angle this time though?
It has pi and it's a fraction.
So that means what would be the units on that? So what are the 2 units we always measure angles in? Like what did this problem use?
Degrees.
Degrees.
Oh, it'd be radians.
That's radians. Okay, so if you're not familiar or you have trouble with the radians, you can change it to degrees so you don't have to deal with that. Does anybody remember what pi over 4 is in degrees? Jess?
90.
90 is pi over 2.
Oh, so 180.
180 is pi.
Oh, I don't remember.
James?
Is it 45?
That's 45, because pi is 180, so this really means 180 divided by 4, which is 45. Changing to degrees is not necessary. If you can graph it without doing that, go for it. All right, so Cassidy, what's my radius in this coordinate?
5.
5. And well, we're going to start out by going 5 to the left or 5 to the right?
To the right.
To the right, because R is positive. 1, 2, 3, 4, 5. Again, that's just a temporary thing, so I remember where to start from. I'm going to erase that. And now 45 degrees. Katrina, we got to go 45 degrees clockwise or counterclockwise?
Counterclockwise.
Let's see. So that's a positive angle.
So counterclockwise.
Let's double check. So when we have a positive angle, counterclockwise, perfect. So if you get stuck, just go back and look at your two rules. All right, so counterclockwise, 15, 30, 45. On my graph paper, the red lines that are on the diagonals, those are the 45s, and they're also the separating quadrants. Okay, questions on that one? So again, that was still positive, positive. Positive radius, positive angle. Let's try positive radius, negative angle. All right, so Jody, which number there is my radius?
5.
So 5, and are we going to start by going 5 to the left or 5 to the right?
To the right.
Yeah, we're going to go 5 to the right. Again, just a temporary mark so I remember where to go. And Ava, you don't have to tell me direction, but can you just tell me how many degrees I'm going to rotate?
Negative 210.
The negative, that has to do with direction. So we're going to rotate 210 degrees.
Yeah.
So now the negative tells us which way. Which way are we going to rotate?
Clockwise.
Clockwise, because that's a negative angle. So we're going to go around starting that way, clockwise. Well, if I go halfway around, how much is that? About, Tom?
What do you want?
If I go halfway around?
It would be like 210 minutes.
So how much is halfway?
Halfway would be 180.
So halfway is 180, so I got to go how much more?
30.
30 more. So let's go halfway around, and then another 15 and another 15. So there's my chord there. So that's 5, negative 210. Okay. Any questions on that one? All right, let's try this one. Negative 3 pi over 2. So this is the first time we've had a negative radius and a positive angle. All right, so Vivian, which way am I going to go for my radius?
You're gonna go clockwise.
Clockwise or counterclockwise would be for my angle.
Oh, so it's a negative 3, so you're gonna go to the, is it like either you go left or right for this one?
It is one of those two options.
Okay, so you're gonna go left,
So we are going to go left how many units?
3.
3. So we're going to start from right there. So we're going to go left 3. And this time I'm going to do something, and you'll see why in a second. So we started by going left 3. And then pi over 2. How many degrees is that? 8? That's 90. So that's the same as negative 3, 90. And Aiden, which way would we go
We're gonna go
for 90 degrees?
counterclockwise.
Counterclockwise 90 degrees from that point. Okay? So counterclockwise 90 degrees would put me right there. Okay. Questions on graphing that one? Okay. What is another way that I could get to that same point besides negative 3, 90? Yes?
Could you do positive 3, negative 90?
So we could do positive 3, which means 1, 2, 3. And now negative 90 needs to go clockwise. From that point, 90 degrees. Yep, that would get you there. Another way. I'm looking for 4. Yep.
But you got negative 3, 270.
All right, let's try that one. So negative 3 means start by going left 3. Now go 270 degrees, that's a positive number, For 270 degrees, we would go
I'm at
counterclockwise. What is it?
I'm at negative 270.
So let's try negative 270. That means we are going to go clockwise. There's 90. There's 180. There's 270. There's one more way. And if you look at the pattern, you've got the negative positive. You've got the positive negative. You've got the negative negative. You're missing one combination you could have. Yeah?
3 and positive 270.
Alright, let's try that one. So right 3. 1, 2, 3. Now 270 degrees counterclockwise, because it's positive. 90, 180, 270. Okay. So what I'm trying to show you here is there is more than one way to get to the same coordinate. This one happened to have 4. Depending on where your coordinate lands, it might only be 3. Okay. That usually happens if you end up with a point somewhere on the x-axis. There's only 3. But other than that, there are 4 ways to get to every point. Now, let's go back and look at a rectangular grid. And let's say I want to get to that point right there. What would be the coordinates of that black dot? Yeah.
31.
Right 3, up 1. Is there any other coordinate that you can write that would get you to that same spot? No. When you're dealing with a rectangular coordinate system, there is only one set of numbers that will get you to a specific location. When you're dealing with a polar coordinate system, there are multiple sets of numbers that will get you to the same location. Most of the time, there's 4 different sets of numbers. Sometimes only 3. Depends if your point is right on the polar axis. Now, we would not count something like this as another way. Go right, and then go around, and then go around again, and stop. No, that's not a different way. Okay, the blue way already accounted for going to the right, and then going counterclockwise. Okay, so the 4 ways are right clockwise, right counter, left clockwise, left counter. Those are the 4 ways. Going around extra times and then stopping, that's just repeats. Okay, but those are the 4 basic ways. And the reason I show you that is because when you do a problem, you may get an answer like 3 negative 90 on your calculator. And if it was a multiple choice question, maybe I wrote it as a positive and a positive, because I like to use the positives rather than the negatives. You'd have to understand that your answer and my answer are the same thing. And the easiest way to figure it out, if you're not sure, you can always just sketch it off to the side, just like we did here, and that'll show you they're the same. Another way you could think about it, we talked about if you have a negative angle, what can you add to it to make it positive? You can add, or you can add or subtract this number, and it will never change your angle. Anyone remember what that number is? Think about it when we did unit circle trig. Like if I gave you an angle like 3,000 degrees, that's going to be too big of an angle to easily think about. So what did we subtract from that angle to make it smaller? Or if I gave you an angle like negative 3,000, we got to make it bigger. So what did we add?
360.
Add 360 or subtract 360. So if you took, let's say you took this one in red. If you add 360 to negative 90 plus 360 is 270. So there are other ways to figure out what these other coordinates are besides just drawing them. You could come up with formulas to do it. But I usually just make a sketch. Okay. Questions on that one? Yeah.
So if this were on the test, like how would the setup be to find my answer?
Well, you're going to see what we're eventually going to do is we're going to be converting a point from polar to rectangular or from rectangular to polar. And when you convert to polar, you could get one of these choices, like this. And it would probably be like a multiple choice. You may get the answer in red on the calculator, and I might write the answer in blue as one of the choices. So you'd have to be able to, with the multiple choice, pick the right option. I would never have more than one right option. Like if this was a multiple choice question, I wouldn't list all these as choices, because they're all the same, they're all right. Okay. But I would pick one of these four.
That'd be one way to mess with people, if you like.
Yeah, no, there will only be one correct answer if it's multiple choice per problem. Which answer I pick, well, it's up to how I want to do that. All right, let's try graphing this one. So this is a negative radius and a negative angle. Okay, so Angelino, for my radius, which way would I start? Which way would I move?
To the left.
Left, how many? 2. So we're going to start by going left 2. And then, Ben, how many degrees am I going to move?
180.
I'm going to move 180. And now the negative tells me which way. When I have a negative angle, which direction is that? James?
Clockwise.
That is clockwise. So I'm going halfway around the circle, and I'm taking the top route to get there. Okay, I'm going clockwise. Now, had I gone counterclockwise on accident, where would I have ended up?
The same.
I would have ended up at the same spot. Whenever you're moving halfway around the circle, if you made a mistake, you'd still land at the same spot. Okay, so that's a negative angle and a negative radius and a negative angle. Questions on that one? Okay, let's try this one. 0 to 300 degrees. Okay, what's my radius in this case? Yep.
This side here.
So my radius, it's a length. It has to be a number.
So
0. So my radius is 0. And what's my number of degrees that I'm going to rotate? Don?
300.
300. Clockwise or counterclockwise? Counterclockwise. So where's this point going to end up? If I have a radius of 0 and I rotate 300 degrees, yeah?
In the center.
It's going to stay right at the pole. So your point is going to be right there for 0. But then, this is the key part, you have to take your point and you want to rotate it 300 degrees. So probably about like that. And the way I can tell if you rotated it, when you used to take the test on paper, I could take a magnifying glass and I could see if you put your pencil there and you spun it. Because it would make like a little swirl, you could tell. And if you didn't have the swirl, no good. But that's what you're looking for. So basically anything 0, an angle is always going to be at the pole. Okay, any question on that? It spins in place. How about if we switch it? Is this point, now the 0 is the second number. Is this going to be at the pole? Pete?
I don't think so.
No, where's this one going to end up?
To the right, I think.
To the right, how many?
1.
1. So whenever the second number is 0, all you end up doing is moving left or right. But you'll always be on the polar axis. Okay. Any questions on that? All right, so we really looked at every different case you could have for the graphing. So now let's look at this coordinate. Okay, 3, pi over 6, which, if you think of in degrees. We said pi is 180. So what's 180 divided by 6? Yep,
30.
30. So we're dealing with the coordinate 3, 30 degrees, which if I graph it, would be right there. So right 3, and then up 2 grid lines. Each grid line is 30 degrees. But what I want you to do with this one is similar to what we did a couple problems ago. I want you to try writing it 3 different ways. Okay? And remember what we said, you can always add or subtract 360 to the angle, and it'll land you back at the same spot. It might be a repeat, that's fine, but just whatever the directions ask you to do, that's what we'll try to figure out. So the first way I want you to write it is with a radius that's positive, but I want my angle to be between 360 and 720. It means I've gone around more than one time and then stopped. Then I want to try to write it with a negative radius and a positive angle. Okay, we did in a couple examples like that. And then the third way I want to write it, I want to go back to a positive radius, but this time I want a negative angle. Okay, so the easiest way to try to visualize these would be to graph the point and then look at your picture and see what happens. Okay, my point's here, and then if I go left, I need to go this much, or if I go right, I need to go this much. Okay, but that's going to be the easiest way to do it. Try to visualize it. Okay, so take a minute or so and try to write that coordinate in red those 3 different ways. Hint would be to graph it so then you can just kind of visualize it and count how you have to move. All right, so the first way they want me to write this is with a positive radius. Without too much thought, we should know what that number has to be. What does my radius have to be if they want it to be positive? Yep, 3. Has to be a 3. So that means I am starting 1, 2, 3 units to the right. Now, they want my angle to be between 360 and 720 degrees. So what direction am I rotating in? Yes? We're going counterclockwise. And 360 to 720 is between how many rotations around the circle? Pete?
2.
Between 2 and
4.
4 would be, that would be 1440 degrees. They want us to be between 720, which is 2 rotations, and 1. 360 is 1. So between 1 and 2 rotations, rotating counterclockwise. That means you're going this way. And then stopping. So you can see how much I went around, and then how much extra I had to go to get up to the red dot. So what would my angle be in this case? Look at how much I went around, and then look at how many more sections I went. Yep?
390.
390. So that's 3, 390. Okay, so there's the first one. All right, let's look at the second one. So this time, R is less than 0. What does my radius have to be to land on the third ring and be negative? Yep. It has to be a negative 3. Let's move this off. All right. And now we're starting at negative 3. 1, 2, 3. Now we just have to figure out which way they want me to go to get to the dot. James, which way are they having me rotate? Clockwise or counterclockwise? Right, it's a positive angle, so we're going to go in the counterclockwise direction. This much. We just have to figure out how much that is. All right. So how much did I rotate to get from where I started to the red dot? Tom?
210.
210. Right? I went halfway plus 2 more sections. Each section is 30. Each section is 15. So that's a total of 30 more past halfway. So that's 210. All right. And the last way they want me to do it. A positive radius, and this time they want a negative angle. Well, so we already know the radius has to be 3. Now let's look at our picture. So we are starting right there. And the angle is going to be a negative between 0 and 1 revolutions in the negative direction. Okay, which way do I go if my angle is negative? John? We're going to go clockwise. So we're going like this. Right, so we know because we went clockwise, it's going to be a negative. Now we just need to see how much. That's going to be negative, how many degrees? Pete?
330.
Yep, it's going to be a negative 330. Right? You're 2 sections shy of going all the way around. If you went all the way around, it would be 360. 2 sections short of that means you're 30 degrees short of going all the way around. So that's 330 in the negative. Okay? So negative 330. All right, so any questions on practicing writing a given coordinate in different ways? Yeah.
The whole second part just throws me off. Like, I don't really know what you're trying to ask.
Like the part after the comma,
Right.
this is telling you what kind of angle they want. So the choices are usually going to be, do they want you to give the answer as a positive angle, or do they want it as a negative angle?
Oh, right.
Both are correct. It's just a matter of which one do they want. In this last one, they wanted it as a negative. They wanted the angle to be greater than or equal to negative 360, but they also wanted the angle to be less than or equal to 0.
Okay.
And negative 330 does fit between those two numbers.
Thank you.
Yep.
How come this one has like 3 different angles that we can do, and like the last one had 4 different ones?
So they just picked 3. We could do more, but we only picked 3 to do here. But oh yeah, there's more. Yeah. All right. So the last thing we're going to look at is converting between a rectangular coordinate and a polar coordinate. Today we're going to specifically do polar to rectangular. All right, when they give me a coordinate in polar, can somebody remind me what are the 2 values that they give you? And not what they stand for, but the letters we used to represent them. Okay?
Radian.
So what's the first one?
R.
So they give you a radius. Yep. And what's the second thing?
The angle, which is. I don't remember the name of it.
What's the letter we use to represent the angle? But it is right. It is the angle, right?
Theta.
Theta. So in polar, they will give you those 2 values. They'll give you an R, and they'll give you a theta. Rectangular is the old way of graphing. That's how we graph things like back in like Algebra 1, geometry. What are the 2 values that you have in that system? It's not an R and a theta. It's yep. It's an X and a Y. So the goal is going to be to turn, and this is a problem we'll do in a minute. We're going to turn an R and a theta into an x and a y. That's what we have to do. All right, so let's plot just a generic polar coordinate. Okay, I don't know the angle, I don't know the radius. I'm just going to plot a point. I'm going to say that it's on that circle, and I'll say the distance to the center is r. I don't know what r is. And this will be my angle. Now to figure out how we convert the r and the theta, so that's my angle, into an x and a y, we're going to make a shape out of what's inside that circle. Anyone have a guess what shape we're going to make? Pete?
A triangle.
Yeah, we're going to make a triangle. And could you tell me how you could do that?
How? Well, make a triangle, you need 3 sides.
Yeah, that's a great start. We want to definitely start with the 3-side approach.
Yes. Well, you kind of have that, although one looks like a pizza. I don't really like pizza.
No, you don't like pizza?
No.
I thought you loved pizza, Pete.
I hate pizza.
So we gotta make that edge to not look like a piece of pizza. So what do we do? We have to make that edge is curved. What do we want to do?
Straight.
So if we put a line in, like maybe right here,
I think that might look good.
it would cut off that curved part, and now we've got a triangle.
Yeah.
So remember, the goal is to figure out the coordinates for that point. We don't want to do it as a radius and then an angle. That would be like counting out this many rings and then rotating that many degrees. That's polar. We want to do it in rectangular. So what I want to know is, starting from here, how far to the right do I move? What do we call the horizontal movement in a rectangular system? That's your what value?
Your x value.
That's your x value. So basically the x value is the length of the bottom side of the triangle. And then from there, we want to know how far up to go. What do we call the vertical movement in a rectangular coordinate system? That's my what? Yep, Angelina?
Y.
That's my y. If you can tell me what the x and the y value are in that triangle, you will be giving me directions starting from the origin. How far right do I go? And then how far up do I go? If you tell me right and up, you've given me rectangular coordinate directions rather than telling me an angle to rotate. So it's a different way of telling me how to get to the same point, but now you've told me in a rectangular way versus giving me the polar coordinate way. So we're going to know this, and you're going to know that. Let's solve for x first. Well, we've done this kind of thing a lot. This is a right triangle. From the perspective of theta, what would be the name of the side that is labeled x? Pete? Which one?
Adjacent.
Yep, that's adjacent. We don't need it right now, but we will. What's the name of the side that's labeled y? James?
The opposite?
That's the opposite. We'll come back to that one after. But we're going to deal with side x first. That's the adjacent. What about the side that's labeled r? Yeah? Hypotenuse. Bless you. So to solve for x, which is what I need to do, that's my first step to get a rectangular coordinate, I need a formula that would relate adjacent and hypotenuse. What trig function has those two in it? Adjacent and hypotenuse. And our choices are going to be sine, cosine, or tangent. Anyone remember? It's from the week before we did the graph.
Which ones are we,
What is it?
which ones are we using?
We're using adjacent and hypotenuse. Yeah.
That'd be sine.
Nope,
Or
not
maybe
sine.
cosine.
Which one? That would be cosine. Cosine of what we get plugged in right there in this problem. Cosine of well, what always gets plugged in right here? An angle. What's my angle in this one? Theta. So the cosine of my angle equals adjacent over hypotenuse. Ava, what's the adjacent side here? X. And Kobe, what's my hypotenuse? R. And remember, you're going to know the theta and you're going to know the r. The only thing you're not going to know is the x. So I just want to get x by itself. How would I get x alone? How about Cassie? How would we get x by itself?
Multiply r.
Multiply both sides by r. That's gone. That's gone. And there is your formula that will calculate the x value of a rectangular coordinate. You have to know the radius and the theta of your polar, plug them in, and you'll get x. Now, let's do this kind of the same thing, but this time we're going to find y. Okay, you'll be given this. You'll be given this. Now you want to find that. So focus on what I've circled in red. I need a trig function that's going to relate opposite and hypotenuse. Lacey,
Sine.
that's going to be sine. So the sine of, how about, Jacob, what's going to get plugged in right there? So r is a length. What kind of thing do you always have to plug into a trig function? The angle, which in this case is theta. Sine equals opposite over hypotenuse. Katrina, what's my opposite?
1.
And my hypotenuse? Okay, so there's a formula that relates opposite and hypotenuse. Now we want to get y by itself. Okay, how would I get y alone? Angelina? Times r on both sides. So converting a point from a polar coordinate to a rectangular coordinate is nothing more than finding the base and the height of a triangle. That's all it is. So it's something we've done before. So there's your x value, there's your y value. Once you have those two numbers, you want to write them like this. That's how your final answer should look. All right, so think. Yep. So to convert from a polar to a rectangular coordinate, you're going to use the two formulas that we just came up with. They'll tell you the radius, they'll tell you the angle. Plug those two numbers into those two formulas. Those are the formulas we just did. Okay. Any questions on the the two formulas. So if you were going to make a reference sheet for the test, those are two formulas I would put on it. Alright, so let's convert the point 6 comma pi over 6. That's polar. I want to change it to rectangular. Now, there's no reason to convert between degrees and radians here. Okay, all you have to do is change the mode on your calculator. So when they say 6 pi over 6, what mode should I be in for my angle? Yeah.
Degrees.
Radians.
Radians, right? If it was going to be degrees, you would see a little circle on that angle. That's pi over 6 radians. Okay. All right, so let me check, make sure I'm in radians. Nope, I'm in degrees, so I'm just going to do that first. Switch over to radians. Now, let's plug in the radius and the angle that we have into the two formulas. You don't have to give me the answer, we'll do that together, but can somebody just tell me my formula for the x value? Yep, Vivian?
X equals radius, the cosine of radius, and times theta.
And can you go ahead and fill in the radius and the theta that we have?
6
Mm-hmm.
cosine and pi over 6.
Pi over 6. All right, and how about for y? Somebody give me my formula for that one. Raymond?
6 times pi over 6.
6 sine pi over 6. All right, let's type those in and see what we get. So I'm in radians, so that's good. Pi over 6. Oops. 6 cosine pi over 6. All right, so I get 5 point, if we round that off, that's about 5.20. And the bottom one, 6 sine pi over 6. Keep hitting pi over 6. You're going to notice when you convert, a lot of times one of the answers will come out to a nice number and the other one does not. That's because this angle pi over 6 is a multiple of 30. We talked about multiples of 30 and 60 when we did unit circle trig. Forget about that 6 for a second. Okay? Just look at cosine pi over 6. When we studied the 30s and the 60s and the 45s, there were 3 numbers that came up a lot. Root 3 over 2, root 2 over 2, and 1/2. And root 3 over 3. I think that one was for tangent, so never mind. Root 1/2, root 3 over 2, and root 2 over 2. 0.866. That's a special number. 0.866. It is this number from when we did unit circle trig. It's root 3 over 2. So this part of the problem I just put a box around, that really came out to root 3 over 2. How would you know that? Well, if you get a number that's 0.866, that's a root 3 over 2. If you get a 0.707, that's a root 2 over 2. So the reason I'm showing you this is because you might see this number written like this. You're like, what? How did they get 3 times the square root of 3? How is that 5.20? Well, let me show you 3 square root of 3. That's the same answer we just got, that 5.19615. And the way they got it is from unit circle trig. This part is 0.866. That means it's this number. If you multiply that number times 6, 2 goes into itself once, 2 goes into 6 3 times, you get 3 square roots of 3. If that seems like you're a little confused because you don't remember the root 3 over 3, root 2 over 2, that kind of stuff, and it was a multiple choice question, and you saw this as the choice for the x value, what you could always do is take the choice that they give you, type it in, and change it to a decimal, and then match it to your decimal. So if you see an answer that has a square root in it, and you're not sure how to work with that, you can take the choices that have square roots and manually type them in and change them to decimals. And if you've done the problem correctly, your decimal will match one of them. Right? So your final answer would be 5.20, comma 3. That's the coordinate converted to rectangle. So let's graph that. 6 pi over 6. That would be about, let's see, 1, 2, 3, 4, 5, 6 pi over 6. Does everybody agree I graphed that correctly? So I went 6 to the right, and then I went 2 sections up to 30 degrees. Now, what I can do, as long as I use the same scale graph paper, I can change the graph paper behind that to rectangular. And if we've done this correctly, that point should land exactly at 5.2, so a little more than 5 units right, and exactly 3 units up. All right, so I'm going to leave that point exactly where it is, but I'm going to change the graph paper behind it and see if that's where it lands. Okay, let's see. Let's take my graph paper. And remember, we're looking for it to be a little more than 5 units right, 5.2, and 3 units up. All right, let me find graph paper. Ready? Really good. Look at that. I wait all year to do that. Isn't that cool? Right? A little more than 5 units right. 1, 2, 3, 4, 5. Right? 5.2. And 1, 2, 3. Exactly 3 units up. So that's the point in polar. And then the same point we had before. Well, that's polar. And there it is in rectangular.
Oh my gosh.
Isn't that cool? I found that out one year and it just blew my mind.
Oh my.
Yeah. I think that's great.
I'm flabbergasted right now.
Yeah, it's amazing. Could do that all day. Polar, rectangle, it's beautiful. Alright, so there's a way you can check it. You can't really check that in your notebook that way, but if you have a computer, you can check it. Alright, so any question on how we converted from that polar 6 comma pi over 6 to getting 5.2 comma 3? All right, and I think one more time, we just gotta look at that again. So there it is in polar, right? Boom, perfect. I mean 5.2, a little more than 5, it is perfect.
That's just,
Yeah.
that just made my whole day.
I hope so. It's a great way to start your day. So that's the homework for tonight. Okay, remember there's only one PDF file in the Schoology because all we did was one section today. Tomorrow we're going to do one section, but it's going to be a half and a half. Okay? So it's 12 to 26 and 40 to 46 evens.